Hello everyone, my name is Ryan Revo, and the topic for today is static versus dynamic routing. First, let us understand what exactly is static routing. So, First, let us imagine a scenario in which you are traveling from your home to your college every day, and you are known of the fixed route that leads you to your college. So, you do not rely on Google Maps because you already know the path. Similar to this case is static routing, in which there is a network administrator which manually configures the route from the source to the destination for the packets. And this type of routing is used in small offices or homes. So now talking about the scenarios in which you will use static routing is when you have small networks, when the network size is small and it has limited number of routes, then you can use static routing, as well as when you want the network to be stable and predictable, or when the network is predictable, you know already what the routes are. In such case, you can use static routing, as well as when you want to have control and security in the routing process, or if you want to add a backup route in case the primary dynamic route fails. In such cases, you can use static routing. So now let us talk about the steps involved in static routing. So the first step will be the administrator who will define the routes. So the network admin manually will enter the routes from the source to the destination. So in this, the route will specify the destination network, subnet mask, and the next hop address. So we will see an example for this in the next slide, but this is the first step. Then in the second step, the router will store this route, which is mentioned by the administrator in its routing table. So then the last step is packet forwarding. Whenever the device will send a packet, and the router will check its destination IP. If it has a matching route which is present in its routing table, then the router will forward the packet accordingly. And if there is no route which is found, the router will drop the packet. So now let us look at an example of static routing. So in this example, there are two networks, network 1 and network 2, which are connected through two routers, router 1 and router 2. So the IP addresses are also mentioned. So the example is that we need to add a route so that R1 knows how to reach the second network using the second router. So in this case, we would need to configure the first router so that it knows how to reach the second network. So in the command that you can see below, you have to specify the destination network, which is 192.168.2.0, and then followed by the subnet mask, and then the IP address of the router. So now let us talk about dynamic routing. So in dynamic routing, what happens is the routers will automatically learn and update the routes to different networks using routing protocols. These routing protocols we will learn afterwards in the next slide. But this is the advantage with using dynamic routing, is that it adapts to network changes such as link failures or new paths. Now, talking about the working of a dynamic routing, firstly, the routers will communicate with each other with the help of routing protocols such as RIP, OSPF, and with the help of this communication, they will update their routing tables. And if a link, for example, goes down, the routers will find the next best path for that route. And then whenever a router will receive a data packet, it will check its routing table and it will forward the packet to the best path. So now let us talk about different routing protocols. So in dynamic routing, routing protocols are used as per the network's sizes and needs. So as per the network size and needs, we use different routing protocols such as distance vector protocol, link state protocol, hybrid protocol, and path vector protocol. So before going into it, let us understand what convergence in networking means. So convergence refers to the process through which the routers in a network will agree to the best path. So as I said before, using routing protocols, the routers will communicate between each other. So, if we talk about fast convergence, it means that the network will quickly adapt and stabilize after there is a change in a certain path. And slow convergence means that it will take longer to update, which will cause temporary routing issues. So now first let us dive into distance vector protocols. So in distance vector protocols, the work it works by sharing entire routing tables with the neighboring routers at regular intervals. And as a metric, it uses hop count, which means that the number of routers that a packet passes through. Now, the disadvantage of distance vector protocols is that it has a slow convergence, which means that it takes a long time to adapt to the network changes. Now, the examples of distance vector protocols are routing information protocol and interior gateway routing protocol. So, in routing information protocol, it will update every 30 seconds, and this will, of course, cause high networking overhead. And also, the max hop count is 15, which means that it can only route packets up to 15 routers. Then talking about IGRP, it uses a more complex metric, which are bandwidth, delay, load, and reliability. Now let us talk about link state protocols, which build a map of the network instead of sharing entire routing tables. And it uses Dijkstra's shortest path first algorithm in order to find the best route, and it has faster convergence when we compare it to distance vector protocols, but it requires more memory and CPU power also. So the types of link state protocols will be open shortest path first and ISIS, intermediate state to intermediate state. So in OSPF, what happens is it will use areas to divide a large network into smaller regions. Now, what this does is it reduces CPU overhead, and then ISIS is similar to OSPF, but it is designed for larger internet service provider networks, and it is used by large organizations and service providers. Now, talking about the hybrid protocols, it is the combination of distance vector and link state protocols. It uses distance vector behavior for small updates, but it uses link state logic for fast convergence, and hence it is more efficient when compared to pure distance vector protocols like RIP. Now, hybrid protocols are best for medium to large networks where both efficiency and simplicity are needed. Now, an example of hybrid protocol is Enhanced Interior Gateway Routing Protocol. It uses a dual, which is diffusing update algorithm to find the best path quickly. And it also will have a faster convergence when compared to OSPF and RIP. So now talking about path vector protocols, it is used for routing between autonomous systems, which are large networks which are run by internet service providers. And in this, the difference is that the routers will exchange the entire paths instead of just the next hop information. Now, the example for this is Border Gateway Protocol. So it is used to connect different internet service providers and data centers globally. So we can say that it is highly scalable, and it is the backbone of the entire global internet. So now let us finally compare static routing with dynamic routing. So first, regarding the configuration, in static routing, it has to be manually configured by a network administrator, whereas in dynamic routing, it is automatically configured and adjusted based on the network changes. Then regarding scalability, static routing is suitable only for small networks due to the manual configuration. However, for dynamic routing, it is ideal for large networks as it automatically adapts. Then, regarding adaptability, static routing does not change automatically. However, for dynamic routing, it does adapt to network changes automatically. Then static routing has low CPU usage since it does not require continuous updates. However, for dynamic routing, it requires higher resource due to constant network monitoring and updates. Then the use case for static routing is best for simple or fixed networks with minimal changes. However, for dynamic routing, it is suitable for large and frequently changing networks.